And then what I'm wanting to do now is I just want to basically get thoughts from each person in the room and everyone online. Just going to ask two questions. One, what's your at least one big takeaway that you had from today's discussions, and one key thing you'd want to see done if we were to run this again? What's the most important thing for us to do? So I'll start with Yi, and we'll just go around the room here, and then we'll do it online. So yeah, just speak into the one big takeaway, and it could be more than one. But from your observations today, both from the competitors as well as the official forecasters, what's your takeaway, and what would be most important for us to do next year?
Oh, that's a very big question. I think one thing that I really learned is there could be multiple alternative ways to do forecasts. What we currently have may or may not be the best way. So there is a lot of opportunity to further explore different methods and also evaluate them against current official forecasts and see how the model performance look like. So I can see opportunities there, and which make me really excited. And for next year, I think to me is two things. One is I think we can do more marketing, so there will be more people who can participate to generate different ideas, and this is really a nice event to exchange ideas, not only for the forecast itself, but also for like data analysis modeling in general. I think is a good opportunity. And the other piece I think is to encourage more sharing and exchange on the not only ideas but also like code and that could, some of them may be hard to interpret, but there is always opportunity I can send to learn from each other. So
awesome.
Yeah.
Thanks. Yeah. Oh, you want to do that?
Godfrey Pesto. Is that what we saw in the agency presentations on the forecast, is that they never just go with one approach or even with one type of approach, like as Curry was presenting, like there's this classic type of forecast with all the new bells and whistles on the statistical methods, but then there's the high C's based index, and it's never like the actual official forecast is never purely an automatic model performance gives you a forecast and you run with that. It's always this large team that tries to make sense of all the supplemental information qualitatively. So I don't know how you would be able to put something like that. That's kind of my question for the next iteration. Like, how could you set up a competition where you mimic that other step too? That is like, I know the analysts individually have multiple models and test them, but the one overall winner was the one who said, okay, I'm going to take a step back from the purely statistical and look at contextual information. So how could you have a competition where maybe the teams don't just do statistics, but actually have a meeting to discuss something similar, like have a streamlined version of what the agencies do, which is talk through the biology and the intangibles and try to pick and choose and adjust according to that. And maybe that gets you closer to the eventual accurate number.
So if I'm understanding correctly, it would be something kind of like what we're doing here now, where there's a preliminary exchange of ideas beforehand.
Or even within it stays within the team. Like if the team had multiple people and you try to, if somebody like Alec had access to somebody like Jeff to say, oh, let's talk about this stuff a little bit. Mm-hmm. You might have had a few more ideas. So maybe it's a multidisciplinary team.
You could do rather than webinars leading up to it where those folks that want to share. I mean, the idea of a competition is that there are sort of different approaches. So rather than forcing everyone on one forecast, you get the multiplicity of forecasts, right?
No, I was more thinking like Team Alec might be not just him, but actually pair up with a biologist who might not.
Oh, I
I've got-
see. So
like,
creating
it's still
some formal
teams,
team.
it's
I
still
see
a
what you're saying. So
competition, but
creating the teams.
a bit
Yeah,
more
yeah.
multidisciplinary that people are, oh, you know, I've got like the CMIST information, but they might not know much about
Yeah, yeah.
uniqueness
Yeah,
on the Fraser,
yeah.
like which grid cell and which month would best give you the annual index for Chilco. Like we might need some local knowledge that doesn't have the large language modeling
Yeah,
capabilities.
like Josh and Haley
Yeah.
were an example of the team.
Exactly. Yeah, yeah.
And it was originally set up as that team format. It was a rapid fire, just get this out. And I think they're the only ones that actually had a formal team together. But yeah, that philosophy. Okay, got it. Yeah, yeah, very good. Yeah, thanks.
Yeah, I think a big takeaway I took today is also that there's no like clear like one method that seems to outperform another, which was not really surprising to see, but it was interesting to see that it was also interesting for me to see the other agency talks that like, you know, they do very similar things where they're considering all the information that's available to them in addition to just like how the model performs through time. But I agree with Gottfried. I think it'd be interesting if you could get everyone to kind of submit their like individual forecasts as like their competition, but then get people to like work together and see if they could like hone in on one to like work together and improve a method or something and see if and maybe it's like putting teams together that have two kind of different skill sets and seeing what kind of happens that way. Yeah. I think that would be interesting because you could have like the individual based prizes and then also like team based prizes and see who like does the team or individual do better. But
I mean, that'd be super easy to do. You just submit multiple teams, have just multiple forecasts. You know, each team, you know, you can put your own individual one in there as team A, and then you combine with somebody for team B. And so the way we've structured the website is that's easy to do. That'd be super easy to implement. It is just you have to come up with folks that you collaborate with. So that'd be sort of up to the competitors, but should be totally easy to run the same competition.
And on the terms of environmental covariates, they're the ones that I use are open access. They're easily accessible, and so if people are looking for covariates for the Fraser, you can give them my email and I can point them in the right direction. So, but they are open access. We're not safeguarding those. So.
I think. Oh, I'm Katarina Vo, DFO. I really thought it was like super fun, and I'm very curious. Out of the people who actually run the forecasts, like, did it spark any new ideas or any things that you want to use in the next year? Or, yeah.
Mike Melnichuk. I was intrigued by the differences between the three river systems in terms of how different models performed in different spaces, both in the Columbia River and in Bristol Bay, where Curry can correct me if I'm wrong, but it seemed like the dynamics were dominated by one single river system, at least in those bar plots that you showed with the Ovando et al. Paper. To a large extent anyways. Those ones seem to be more predictable in the sense of the different teams largely got those pretty right, whereas the Fraser seemed to be much more unpredictable. And I just wonder if in future forecasts, throwing in odd different populations each time this competition is run could keep people on their toes in the sense of not leading to that predictability over time.
Rephrase that again?
So I guess as people do this more and more, they're going to get used to what works for these systems that we saw, for these particular populations within the systems that we saw today. But drawing different subpopulations within these systems each time, or different subbasins within each of these, for example. So not always the same 8 and 5 and 1 each time. That could keep overall forecasts interesting.
Katrien Michielsens. Yeah, so what one big takeaway is for me is that I do realize that in the Fraser system, we do have this certain amount of inertia in making changes to the forecast, because it's a huge machinery every year that gets put in motion, and for new methods to be introduced, they need to be vetted through certain processes, and it causes a lot of inertia. So I think having an opportunity like this to showcase some different methods might, again, give a result in a push for seeing some of these new methods be equally explored and integrated into the overall assessment forecast system. So I think it's a really good thing to do, these types of competitions. Then the most important to do for next meeting, one of the things that I also realize is that for Fraser Sockeye, I mean, there's a lot of work that goes into the data. And for 2024, I mean, we were already having the lowest forecast ever. So there's a lot of also detailed data, even that is not yet an official run size estimate, but an in-season estimate. So we wanted to provide the best possible data. But I also realized that that hampered the participants to the competition because, I mean, as people already alluded to, it's too complex than the data that gets provided. So to make it, or to simplify our data to a certain extent for this competition. So rather than providing the best available data, and the only problem then is like, it's the managers don't respond very well to data being out there that is perhaps, I mean, incorrect is a big word for it, but not the right data to be spread or to be shared with others. So, but yeah, I think more work can be done there for the next competition.
Hey, Joshua Zunner. So I think I was surprised that a lot of the submitted forecasts were not just comparable, but in a lot of cases were more accurate than the operational forecasts. If you had asked me last week, I would have said there's no chance that would have happened, given that all the people who run the operational forecasts, salmon biologists, been doing this for years, have gone through lots of methods, have all the data available. I would have thought those would have been far more accurate than anything that all of us did as essentially side projects for our own, to humor ourselves. So I was quite surprised that even very naive, simple models that were built very, very rapidly, in a lot of cases, not by salmon biologists, were competitive with those that are done in an operational context. As for the next time this runs, one of the things that me and Haley ran into was that we had no way to judge whether or not our forecast model was any good, and that we had no frame of reference as to how good the operational forecasts were. So making the historical operational forecasts actually available so that there's some frame of reference as to if your forecast is, consistently within 10%, like, okay, yeah, that's comparable to what the operational forecast is, or that's way better or something. So there's some frame of reference. I think that's particularly helpful for people who are doing this for the first time.
Yeah, we can certainly do that, although that might introduce bias too. So, but yeah, for sure. Yeah, thanks, Josh. Yeah, Jeff.
Yeah, it's just thinking about this, and I thought I'd throw out what TAC used to do before they chose me. I had a low bar. What they used to do was take the previous 4 years runs, add them up, divide by 4. That was their forecast. So it was a low bar to allow me to do the forecast. But yeah, I was on one hand surprised that the Columbia Basin was all I looked at, and so the sockeye forecasts were fairly similar to. There were, some were better than ours. The other hand, it doesn't surprise me. Everybody had the brood ear data, and they say all you really need, if you can get that Okanagan 4 component right, and I didn't see any breakdowns by age class or anything like that, but if you get that Okanagan 4s right, you're on your way. In the Okanagan, the Wenatchee 4s are a problem. That may be interesting in terms of, I haven't looked at the models, or I probably don't have the expertise. Used to do modeling, but different sorts of things. But it would be interesting to look closer at that acoustic trawl survey thing, or just smolt through adult survival, I guess, for 2 ocean fish. And there's more I could do, and I need to in the next year looking at that.
Yeah. All right. Well, Curry, you raised your hand, and you'd be the next person to go past too. So go for it.
Yeah, a couple of things. One, it was really cool to see Brian's CMIST approach. Kind of usually we think about kind of a couple different ways of approaching gridded sea surface temperature data, right? You can draw your box, you can take the average, you can reduce the spatial dimensionality and come up with your index, but regressing your comparison of what you might think of as the highest correlation conditions against what you see in a given year, I think is a pretty cool way. And then if I understand correctly, you then took the slope coefficient and used that as your index, which was really interesting. I guess the other one is sort of thinking about the power across methods. So, there's two ways to approach that. One is to sort of consider on a sort of model by model basis, what is the performance over a set period of time, and then select the best one. The alternative is to take an ensemble approach. And so we looked at that in the 2022 paper. If you take the predictions from the various models and you use those as input features to a boosted regression tree, for example, you can use those predictions to come up with an aggregate prediction that's going to leverage their performance in the past. You can do the same thing with inverse variance weighting, but another way that we might kind of look at approaching this problem. The other thought is that, for future iterations, rather than, in addition to looking at a given year, right, we want to know about performance over some standardized period of time using a standardized methodology, right? And so most people have probably calculated that in the background, but it'd be fun to have that submitted as well in order to look, okay, if it did well in 1 year, would it have done well over the preceding 10 years or 20 years or whatever it might be, kind of a set period of reference.
Yeah, and that wouldn't be that difficult to do because you just have to put the numbers in basically. Just like we're running, you rank them same way we rank them for year one, just average it out over the three who got closest over time. Or maybe you've got a better suggestion, Gary.
Well, I mean, you need to do it in a standardized way, right? Like you can do it, leave one out, you can do it one step ahead. One step ahead has some value in that, we have these unpredictable regime shifts on occasion and it might better account for the information we have in hand at a given time. But as long as everybody agrees to using the same methodology and we sort of operate on the honor system, that works great.
Yeah, well, let's explore that a little bit more because that's just adding another set of prizes to the competition. That shouldn't be that difficult to do. And I think Dan Schindler was talking about this, doing like a retrospective 10-year analysis on it, see what models perform the best. Cool. And so anything else on your end, Curry?
I mean, I'm curious, and maybe others can chat more, but how folks are confronting this short time series problem, right? This is one of the fundamental challenges. We apply more complex methodologies. And so there's different ways that you can try to get around that, but I'm curious to hear from others, Tanya and Sam and others about how they approach that problem.
Cool. Thanks. All right. Well, let's I'll go with I guess Brian Burke next.
Yeah, thanks. I'll address Curry's question there first about the short time series. When you said something about 6-year time series, I'm like, my jaw dropped. Because I'm used to dealing with like 20. So yeah, it's a problem, and it limits what you can do. But I don't have any solutions. Just deal with it. I guess a couple of thoughts. The CMIST index that I presented, I think it has promise, but to be honest, it's a little unsatisfactory to me because I know a lot of forecasting, a lot of the need that was presented today for forecasts is one step ahead. What's going to happen this coming year? We want to set harvest limits or whatever, hatchery operations, whatever it is. But I like to think about the longer term abilities, thinking about climate effects and what's going to happen in 10 or 20 or 30 years from now. And so a lot of these methods that we talked about are using correlations, and the CMIST index, it's flat out a correlation method. And so I don't know, I feel like as much as they can be useful, I still want to push the envelope towards how do we link these things to a mechanism that can be forecasted longer term. So I don't know. That's sort of a bittersweet kind of way to think about it. But and then I really like the idea of maybe combining teams in different ways. Some of the modeling approaches that were described today were really cool. I would love to learn more about them. But I know that I don't have time to actually do them. So working with somebody who is intimately familiar with them would be fun. And then I guess the last thought was reiterating that a lot of us are doing this just because it's a fun thing to do and don't necessarily have time to devote, to spending a large amount of time on it. And so the more we could prep ahead of time, particularly with the data wrangling, the better. So yeah, there's just some random thoughts, I guess.
Yeah, that's awesome. Yeah, thanks, Brian. Next, or to the right, is Sam Ermy. Sam?
Yeah. Well, yeah, let me think. Remind me what your two questions were.
Yeah, two questions. So your big takeaways from what you've seen here from the breadth of approaches,
and then what would be,
and then what would you want to do differently next year? If there's one thing you could change, or more than one thing, what would it be?
Yeah, I guess my big takeaway, I think, is there are a bunch of different approaches that were presented, but I was kind of surprised, I was pleasantly or unpleasantly, by kind of how much on the same page everything ended up. Like, there's some different modeling approaches, but it kind of, the same variables end up being important in all these models, like, whether you're doing basic regressions or the nearest neighbor or dynamic models or, whatever. It's like, okay, escapement, siblings, maybe SST, like that gets you a lot of the way there. And yeah, just kind of glancing over the predictions for all the different rivers, like, yeah, they're all kind of in the same ballpark in terms of, how far off they are. So yeah, I don't know. I just thought that was kind of interesting. And thinking about next year, like, yeah, I don't know. I think the data wrangling thing, like Brian said, and kind of like I said earlier, I think that would make it a lot easier for us, enthusiastic amateurs to get into it and not spend too much time, formatting brood tables or whatever. Like, I guess I'll share one thing that happened to me while I was working on this. I was getting these really excellent predictions at one stage and was like really psyched that I had cracked this problem open. I was going to wow everybody. And then I realized that I'd been adding up the ages wrong from the brood table, and I was using, this year's returns to predict this year's returns. And the only reason it wasn't a one-to-one line, is I had that dropout layer in the neural network that was, introducing some stochasticity to it. But anyway, it caught that problem. But yeah, I think one idea, the sort of prediction, one step ahead over the time series or over some 10-year time period, I think that would be an interesting prize or other layer to have, just to kind of, assess the models over a little bit of a longer time period, so that, we're confident we're not just, getting lucky in this year. But yeah, I know a bunch of things I want to do differently.
Yeah, that's very, very cool. Tanya, how about you? What are your key takeaways?
Got very bright here. Yeah, so I guess my takeaways was that people have a lot of very complementary skills and I guess access to information. So like, yeah, some people really have a lot of access to data, which I didn't, and or access to knowledge of how to use different modeling or analytical approaches, or they have biological knowledge of the system and how that sort of works. And I think, you know, bringing all those together, I think would be of a lot of value. And especially given that people specialize in different things and have a limited amount of time, sort of dividing and conquering in that respect, I think would be super cool. And, you know, bring in the best of all the worlds. Yeah, as far as what to do next, yeah, I definitely second the making, I think I mentioned this in the previous workshop, making the barrier to entry lower in terms of the data and not having everyone have to repeat the same lengthy process of data wrangling, which could really just be done once. And so the people aren't duplicating effort on that in that respect. And also then making the historical forecasts available for some sort of step ahead retrospective analysis, which is what I did when I could, as far as I called it lead feature out, but retrospective step ahead, it's the same thing. So to see like, so that it's not simply based on a single year, it's over a period of time that which you can evaluate forecastability. So that's what I got.
Thanks, Tanya. And now to the winner, Alec. what's your big takeaways and your thoughts for next year?
Well, I guess one thing that bothers me, and it's universal in fisheries, is that an awful lot of administrators and especially industry people want the number. You know, they're looking for an exact number that it's going to be, and as we know, that's ridiculous. What I'd like to see, and I'm as bad as anybody in doing this, is some kind of an estimate of the precision of the number you give. And you know, it doesn't have to be really sophisticated. Just, do you think it's imprecise, precise? Anything would help. Then once we have that, it gives us another opportunity to combine models, because that precision is really necessary to combine models. And I'd like to see some sort of a model averaging investigation to see if there are ways we can combine models to do better than any single model. Maybe not, but it'd be worth a look. That's my suggestion.
Do you have any examples that come to mind that you've seen in the past, Alec?
Well, model averaging is a really standard approach. I don't have anything offhand to demonstrate it with, but it's pretty well known as being a good way to go. If you have a whole bunch of different estimates, chances are combined is going to be a better estimate than any single one of them. But let's take a look. Let's see whether it works.
Yeah, totally. Yeah, Curry, your thoughts?
Yeah, no, I mean, my thoughts are in the same place, right? These sort of ensemble-based approaches can be really useful in these sort of prediction problems, and it can be kind of within a model framework, right? So one of the ways that we've done this in the past for different kind of sibling regression models you can AIC weight the different models that are used for prediction. You can inverse variance weight based on past performance, either within sample or out of sample, probably ideally out of sample. And you can extend that if you have multiple sort of fundamentally different forecasting approaches, as long as you have a consistent time series over which performance is evaluated, which makes it fairly trivial to do.
I'm just thinking from a process perspective. So let's say we run the competition. Well, maybe I'll give some of my thoughts first, and then we can jump into that stuff. So, sorry, go ahead. On this topic, yeah. Oh yeah, there we go.
Sorry. On this topic, me and Haley were talking about this on Monday after you showed the full results. Yeah. At this point, you can do this right now very easily. You drop out the operational assessment and then just calculate what the mean forecast across all of the submitted models are, and that's your model average, and then recompute your absolute percent error, and then compare, is that better than the operational assessment? Because me and Haley were thinking that, particularly with the with the Fraser stock where it seemed like there were some that were positive, had positive error, some were negative. Do those average out to zero? Do those average out to like 1% error or something? It seems like all the Crystal Bay stocks kind of all did the same thing. So those probably, it might not make a big difference there, but it seemed like for Fraser, where there were estimates kind of all over the place, they might really average out into something fairly accurate. And that's something you can do right now, like very easily, like within probably like 10 or 15 minutes in Excel.
Okay,
So.
well then let's definitely do that for sure. Anyways, let me sort of go through some of my thoughts, but let's just jump into that because I think I want to figure out how that would fit into the process in terms of, I think, the cycle of one of these, where that would fall in and how that sort of integrates into the competition. Yeah, so I know what I was thinking, my takeaway, certainly access to covariates. If we can make it easier to get covariates into the hands of the participants, that would support it, because I kept hearing that over and over. I didn't have access to covariates, so I didn't use that in the model. That would have helped. So that was one of my takeaways. More time to run the competition, like Kaylee or Tanya, you were saying you were out at sea and you came back and you had like a narrow window to run your model when you were back out at sea. And I know we're all very busy people, and this isn't the driver of our time. But if we can find a way to expand out that window of time that we can spend on the data rather than wrangling the data, and more time working with the data and on the models, that could be a benefit. Is that consistent with that's fair assessment? Yep. Another thing I really found quite interesting, almost everybody that spoke said they saw an opportunity to make improvements. They didn't say, oh, this was the best I could do, I can't see any other way. Everybody was like, oh, there's some other ways I could do this. I could do this better. So I get the impression that if we were to follow an iterative path, which is what we do in the tech sector when we're getting better, when we're addressing uncertainty in the tech sector, it's always about rapid iteration, how fastly you can iterate and take each cycle and learn from each cycle to improve the method. I get the impression that might yield significant benefits in terms of our capacity to improve the forecasting in this method. So those are sort of my takeaways. Anybody have any objections to that, or is that consistent with what other people think too? That makes sense? Okay, I just want to make sure I'm not off base on this. I guess getting back to, if we're going to run it again, and it's still an if, I'm not sure I got the bandwidth to do this, but I get the impression that there's value to this. I get the impression we could probably do better if we run it again, and we could probably expand the capacity, because right now we almost have a critical mass of people who are in this space. One thing that I found is very effective in scaling things up, we certainly seen this was the Washington, D.C. chapter, is each one of us have networks. And if we can tap into our networks to reach out to who we can recruit on board. So I still want all you guys participating, but who else can you bring on that's within your space to say, come on, let's give it a run, give it a try, sign up and test your theories against the actual runs that are coming in. I think we could probably scale up the number, and this is where I was thinking some magic will come in, and I could be totally wrong, but if we get, let's say, if we can double it, maybe to 16 teams, maybe 20 teams, and we get bigger runways and covariates, we'll start seeing a huge cluster of covariates starting to appear, which is what I really wanted to see, is which covariates are repeating themselves. And I did see it kind of maybe on this, like Alec, when you were talking about the covariate, your covariate essentially was the El Nino. That was the thing you were looking at as the thing that was driving it. Brian, your whole model is based on sea surface temperatures, so that's the covariate. And I think somebody else included that as well. I can't recall. I don't know, Sam, if you had mentioned it, but somebody else had talked about climate. So that was kind of a covariate. I want to see a lot more of these other sort of covariates integrated in these models. So anyways, Curry, you've got your hand up.
Yeah, just sort of a general thought. One thing that I've thought about a lot is kind of what the overarching objective is. Of course, like a mean unbiased prediction is sort of number one, but as the previous speaker alluded to, right, our sort of risk around zero for an unbiased prediction may not be symmetric, right? There may be a different cost to an over forecast versus an under forecast. from an industry planning perspective or a stakeholder perspective. And the same thing when it comes to extreme events. You know, we tend to place a premium on sort of forecasting whatever works best, but really we probably care about when we have a run failure or an extremely large run that outstrips processing capacity. So thinking about those in the context of forecast performance is also kind of interesting.
Yeah, the edge cases. What are they? Black swan events, stuff like that. Is that? Yeah. Interesting. Yeah, Brian.
Yeah, just a thought, Sean, related to your comments about like expanding this. You know, in the Columbia, I think there's more attention on Chinook than sockeye in terms of forecasting, and so, and you know, a comment earlier was related to kind of keeping us on our toes and having the things we're forecasting maybe shift around from year to year, and so maybe. You know, either adding or replacing some of these populations with some Chinook populations or something like that would attract additional people to this effort.
Yeah, it's super easy. The way we structured the website, it's scalable. We can run dozens of competitions on that website. Now, I haven't put a lot of energy into it. We set it up in my park pit because I've got a business that I'm running, but we can certainly come back to it. I've got a developer and a designer who are really quite top notch. We can look at making iterations on that. My hope was that we could just have that place as an easy place, a portal where you can sort of make your predictions. I don't think it's as important as I was thinking it was in the early stages. I think the groundwork is just making sure we reach out to people, let them know what we're doing, making sure we're prepping the data, all that stuff. The website is really sort of secondary. But it is structured so that we can run multiple competitions simultaneously. So we can still run. I think there's value in repeating this because this is where we can see if we're getting better. But in addition, we can do a Chinook run or multiple runs on Chinook for any of the forecasters that want to jump into Chinook. That's certainly within the realm of possibility. So yeah, Sam, you had a question?
Oh no, I was just thinking about Curry's comment. You could do Price is Right rules for the predictions, you know, as close as possible, no higher.
Price is Right rules.
Oh, Price is Right. Love it. Well, it is interesting because like Jeff was saying, you know, there's a cost to forecasters when you're saying it's going to be high and it comes in low. So there's a tendency to err on the side of caution, and you get a win if it's like, even if you're way off, it's this run's still high. There's a perception that there's not as much problem with that side of the forecasting. So, but yeah, I don't know.
Yeah.
Is that what you're thinking, or you're thinking differently?
Oh yeah, I don't know. I don't know if it makes sense for the actual competition, but you can think of all kinds of fun cost functions to, you know, criteria for hitting the target.
Over.
Mean squared error if you're above, you know, mean absolute deviation if you're below, kind of thing. Whatever. Not seriously suggesting that, but
hey, this is an opportunity to bounce around ideas, right? So yeah, Alex.
Yeah. First of all, the Salmon Prize is in a really wonderful position to take possession of all of these combined products and have the Sean Simmons index. And
know nothing about this stuff.
Yeah, and so that'll motivate you to keep up the energy. I'm half joking there. Only half though. The other part I wanted to say is that although I mentioned model averaging, and we immediately think of model averaging as seeking the mean that's the right mean, another way we could look at it is considering all of the predictions that get submitted and letting that define the envelope of what might happen. And that might be a very useful product, because really we're having a hard time finding the envelope. That's all I wanted to say.
Yeah, thanks. Tanya.
I guess following up on Sam's comment, you could totally design some error metric or cost function that, accordingly to meet, whatever we think is important as far as management goals. What was I going to say? Oh, I guess they're maybe they honestly have to reinvent the wheel. There's actually like quite a few publications. I'll put one in the chat of an actual like forecast competition for dengue that has sought, several different models, did some ensemble forecasting and stuff like that. So like there's precedent for these sorts of things in the literature already. And I know that there's other ecological forecasting competitions out there. So we can kind of look to them for other sources of inspiration, I think.
Very cool. Oh, you're on mute, Tanya.
Oh, I'm done talking.
Okay. I guess getting back to what you were saying, Josh, about we could do that model averaging. I'm thinking in terms of the competition, if we're thinking the cycle, because I want to extend the opportunity to participate. So maybe leading up to it, let's say we started April, May, June. We had a 3-month window where we open it, let's say April 1st. So that gives us a couple weeks to get ready, start seeing if we can get some additional covariates. We'll add them in as we get them. Run it again to June 30th because that time frame seemed about right. And maybe leading up to it, we've got maybe 1 webinar, 2 webinars where we could do something like this. And if people, like you were saying, Brian, you'd like to explore other models where we could have people team up. So what we do is invite as many people to this webinar as possible. If you see somebody, we'll just do a round of introductions. You see somebody you want to team up with, there's an opportunity. Maybe we do it end of April, end of May. Well, end of April, probably the best time. And then you've still got 2 months to go through the data, develop up the models, get it in by June 30th. Then everything comes in, we evaluate all that data, and then we could do the mean based once we've got that in. That'd be like, we could have something maybe, I don't know, summer's going to be time we probably don't want to do much work, but maybe early September, we regroup and we go through, this is what all the forecasts said, here's what the mean said. And we'll actually have some preliminary data and stuff by September. And the idea is next year's AFS conference, we do this again, and we see, have we moved the needle? I don't know. I love the iterative approach because that allows us, we know what cycle 1 now looks like. Did we move the needle cycle 2? Yes or no? And maybe we can expand a couple of things like Alec, I love your idea about how to get variation integrated in this. I have no idea, but I think that could be really valuable. So we'll think a little bit, and I guess Alejandro and myself, we've got some work to do. We'll probably reach out to everybody here, and just out of curiosity, I probably don't have emails for some of you folks in here. Who here wants to be on the email list for this moving forward? Well, you guys are on the email list, but I think I'm missing the email for it. You guys interested in this? If you want to just write down your email, I'll grab that. Are you interested?
Sure.
Okay. I just want to make sure I do the data capture. But aside from that, any final notes, any thoughts? I think we're almost at time now. We've got 2 minutes left.
No, just to say thanks for your hard work, Sean.
All right, everyone. Well, thank you for all the help from everyone, and we'll see what round 2 looks like. And thank you online.